Guys, we're going to look at section 4.7, simplification of a force and couple system. Okay, simplification of a force and a couple system. Okay, before I go into any of this discussion in this section, I just want to give you kind of my view of the essence and the main idea really of this section. If we have a beam, right, and actually we can see this in figure 435, okay, the bottom one. If we have a beam, or any body actually, any object, a body, and I apply a force there, and I ask you, what effect does that force have, right, on this body? Well, you may say that what you've been taught so far is that if we choose a point O there, okay, then that force is going to cause a moment about that point O, which is absolutely true. That force has a rotational effect to want to apply a moment on this beam, a clockwise moment. Okay, I'm pretty sure everyone has got that. But what we need to also see is that that force also is the effect that force has is also to cause this beam to want to translate. Okay, these two words, translation and rotation. Okay, so thus far what we've been looking at is just the rotational effect of the beam, of the force. You apply a force here and it causes a rotational effect. But we must also see that this force also wants to push this beam down, right? Does that make sense? I mean, if I apply a force here on the beam, then surely we need to understand that force wants to push the beam down. But it also, and I'll elaborate on the rotational aspect now, it also wants to cause a rotation of the beam about, listen now, any point that's not on the line of action of the force. Okay? Let's just look at this now. At a point there, along the line of action, what effect will that point on the beam see? It's only going to see a force, right? Because the moment arm, if I'm trying to calculate a moment equal to Fd, what is d at that point? D would be 0. What if I move this point and I want to look at what happens? Guys, the point that I'm trying to make is, what we're trying to see is, if I have a force acting on a beam, what is the effect in terms of translation and rotation at any point on the body, on the beam, on the object? What effect does that force have? That's the question we want to ask. If that point is along the line of action of the force, then all that point is going to see is a tendency to want to translate, meaning move in a straight line, right? That's it, because there's no moment arm. So at that point there's going to be no rotational effect. There's going to be no moment. What if we begin to move away here? What's actually happening there? And we'll go into the actual explanation of this. But what is actually happening there is you have a force, right? That same force, but you also, because now, okay, this is hopefully is not too confusing, but at that point, that force also, you have the tendency for it to push it down, but because there's now a moment arm between the application of the force and a point, you're also going to have a moment there. You're going to have a rotation there. So again, what are we trying to look at? We have a force and we're trying to see what effect that force has at any other point on the body. And as we move away from the force, from that point of application, we still have the tendency to translate because we're applying a force on the body. If we're applying a force on the body, that whole body wants to move down. But the further you move away from that point of rotation, there is a greater moment that force is causing about those points. Okay? And the moment about that point will be the largest because it is the furthest from that point of application. Yet the body, at that point, the body wants to experience both a translation and a rotation. Okay? So I know this is maybe conceptually a bit difficult to understand, but all you need to ask is, what effect does that force have at any point along this body? At any point on the body, what is the effect of that force? The point there, it just has a translational effect. There, it has a translational and a rotational effect. There, it has a translational and a rotational effect, but the moment is getting larger and larger and larger. Okay? Now, how do we actually work this out? Let's have a look here. I'm going to redraw this. If we have the force there, and we want to know what is happening at that point there, let's call it O. This is what we do. You take that force, you apply it at the point of interest, right? But then, in order to make this an equivalent system, you have to cancel out. So if that is F, right, and we want to find out what effect does that force have at that point. Take that force, apply it there, F, and then apply an equal and opposite force, minus F. Now, what do you see? What do we have here? Right? Because that cancels out, right? So we have an equal, we have an equivalent system here. But now, what do you see is happening? We have a force over there plus a couple moment. This is a couple moment. Okay? So this is, and how do we determine the couple moment? It's the couple moment is simply equal to F times D, where D is the perpendicular distance between the two lines of action of the force. Okay? So again, what is the effect of F at any other point, or any point? I mean, it doesn't have to be any other point. At any point on the body, what is the effect of F at that point, guys? It's just a pure translation. What is the effect of that F there at that point? Take that force, place it there, cancel it out, and then what you see is you've got a force plus a couple. A force plus a couple. So at that point, you've got a force, right, plus a couple moment. Okay? So again, that force has an effect that at that point it causes there to be a translation and a rotation at that point. And you can do this for any point on the body. Okay? So that is the initial idea. Please go and read up on this section here. Okay? Go read up on this section under 4.7 and see if you understand what I'm trying to say here. Let's see here. Yeah, it's okay. I think that's fine. I will carry on in the next video with some more information.